Hello guys, welcome to another video. Today we are going to solve another question which is reach the end of an array with minimum number of jumps. Basically what the question says is we are given an array. That array can have any number of elements and the element can be anything. So it can be 1, 3, 4, 2, 1, 9. So it contains 0, 1, 2, 3, 4, 5, 6 elements, and you have to jump over this array one by one, and you have to reach the end with minimum possible number of jumps. So for example, this is a person and this can jump one time only. So after one jump it can reach here, and this is the number of jumps it can take. One jump, so after one jump it will reach here. Now it can take three jumps, so it can come here, here, or here. So this is three number of jumps, and in these three number of jumps it can take any number of jumps possible from any place. So if it comes here, it can take four jumps from here. If it comes here, it can take two jumps. If it comes one here, it can take one jump. So whatever the maximum reach is, we will take that. That is 4, 1, 2, 3, and this. We will take this one and we will come at the end of an array. If we come here, it will also come at the end of an array. If we come here, it will also come at the end of an array. But if it was 1, then we have to do another jump, meaning that jump will increase. So we need to find how we can, in the minimum number of steps, we can cross this array, we can jump off this array. So basically the brute force approach will be to go from here and one by one till the reach point. We can check for the maximum reach element in on that array, and just take that maximum point, and after that, from that point, take the next point, take the next point of the maximum element and reach that. You can do so, and that should be a brute force approach, and that will take you around big of n square time, and that is not optimal because you will be using two loops to solve that. So what will be the optimal approach? Let's discuss the optimal approach here. So the optimal approach says that you need to traverse this array, and you have to actually have two variables. That is max reach, meaning from start where you can reach, that is the maximum reach you can have. Second is the number of steps remaining while going after it. And there should be one more variable where you have to store the jumps, how many jumps you have done. So total three number of elements you should have. So in starting, you will place your pointer here and make this jump to be 1, and whatever is here, just assign to it to the max reach, because that is the maximum reach you can have. That should be 1, and also assign it to the step, that is the number of steps you can take. Now what you have to do here is you have to decrease these steps, and for every step you take, for example I is here, you will come here, and this step will become 0 because you are doing I minus minus. Here you can see 3 is the reach. What you will do here is whatever is the value of I, just add this value to I and see if the max reach is maximum. This 3 plus 1 is 4. 4 is greater than max reach. So replace the value here. After replacing the value, the steps value is 0. You don't have any further steps. So there is a condition that we have to follow. If steps equal to 0, then what we have to do is we have to first increase the value of jumps. After that, we have to check if I is greater than equal to max jump, oh sorry, max reach. If I have crossed the element of max reach, that means that you can't go for any further, meaning you cannot jump over the array now. So that means you cannot cross it, you have to return -1. If that is not the case, you have to count the remaining steps that you have, because steps value is 0 now, and now you need to know what are the remaining steps that you have. So steps will become max reach minus I. This will give you the remaining number of steps. Okay. Now I is here. Replace the number of steps. Max reach is 4 and I is 1. So steps remaining is 3. Now what we have to do here is increase I, decrease step, and check the max reach. 4 plus 2, that is 6, and max reach is smaller than 6. So we will replace 6 here. After that we will go here and decrease the I, because steps is not 0. We will not go into this block. I comes here. 3 plus 1, that is 4. That is not greater than max reach, so it will be like this only. I will then come here and it will become 0. 4 plus 1, it's 5, and it is not still, it is still smaller than max reach. So I is here, max step is 0. So we will increase the jump. So earlier we didn't increase the jump, so I have increased twice. After that, if I is greater than max reach, I is at 4, max reach it is at 6. So we have not crossed max reach yet. So we will not go inside this. The remaining further steps is max reach minus I. Max reach is 6 and I is 4. 6 minus 4, that is 2. So the max reach value is means the remaining number of steps is 2. So we will go here, and when we reach at the last remaining point, there is one more condition that we need to check. If I is at the last point, that is n minus 1, then we need to just simply return the jump, because that those are the number of jumps that we have taken to reach the end of an array, because we only needed to find how many jumps we need to reach an end of an array. So that is the solution. Now let's look at the code. So guys, this is the question. Now let's look at the solution. For this, we need three variables as explained in the solution. So we will create those three elements here. So those three elements were, first we need to find the length of the array, that is n. So that becomes four new variables. So nums dot length. After that we need to find max reach, that is nums 0, if you remember correctly. Also we need to find the steps, that is also num 0, and for reaching this point we have taken one jump, so the jump will be 1. Now we need to do looping for int I equal to 1, because we already have initialized nums 0 here. We have consumed num 0, so we will be starting from I equal to 1. If I is less than n I plus plus. Also, before doing this, we should actually check if the if n is greater than or less than equal to 0 or not. If the array doesn't have any elements, then we cannot jump, na? So we can just return 0. So when we go from 1 to n, what we need to do here is we need to check and decrease the steps and check for the max reach. So what we will do here is, if max reach, or we can do this, max reach is equal to math dot max. Whatever the value of if max reach is max, then it will assign max reach. If nums of I plus I is max, then it will just assign the value of nums plus I plus I. That will become your max reach. Here our steps is decreasing. This is this. And before we do all this, we also need to check if we have reached the end. If I is at n minus 1, if we have reached the end, we just need to return the jumps, because these are the number of jumps that have been taken to reach the end. After doing this, we need to check if steps is actually 0. If steps is actually 0, then we have to increase the jump, because we have just taken a jump. And we also need to check if I is greater than max reach, because it should not be greater than max reach. If this is the case, we need to return -1, because we cannot jump. If this is not the case, then we need to simply change the value of value number of steps that we have, and that will be max reach minus I. If the loop is over and we have not returned jumps, then we really know that we cannot jump over. That is return -1, because we have to return something at last. It will be returned here or here only, but for the sake of the function, because it requires something at the end, we are returning -1. So let's run this solution and see if it is okay or not. Oh, it passed. Now let's submit this solution and see. Oh, sorry. If it only has one element, that we don't need to jump now. That's why we have to check if n is less than equal to 1. If that is the case, then we don't need to jump. That's my mistake. So as you can see, the solution is passed. This is the only solution that we require, and it is simple. You can watch the explanation again if you have missed something. And let's meet in the next video. Thank you guys.